Hello, very good evening, guys. Welcome to BYJU'S exam prep. Very good evening, all of you. I hope everyone is good, fine. And today we are gonna practice a very important questions from the engineering mechanics. So before starting the session, please do let me know whether my audio and video all good, all perfect. Hello. Yes, good evening, good evening. Sorry for the delay. Actually, Windows का update आ रखा था और आपको पता है Windows अगर update होता है तो खत्म जब तक नहीं होता देन अनलेस अनटिल इट इज नॉट बीइंग कंप्लीटेड वी वोंट बी एबल टू स्टार्ट, है ना? यस, गुड इवनिंग। यस है भाई। लेट्स स्टार्ट। लेट्स join the quickly join guys, session is live. Okay, yes, good evening, very good evening. All right, fine. So today we're gonna practice some very important and good level of questions from the engineering mechanics subject, and definitely our main objective is GATE exam and along with that ESE exam also. But if I say from competitive exam perspective, GATE में इसका weightage is good. The questions level are very good. So we'll be discussing some moderate to difficult questions. Many questions will be 2 marks. Only one or two questions or 2 or 3 questions will be 1 marks problem. Okay. Yes, good evening, very good evening all of you. I hope everyone is good. All right, sorry for that delay. वो थोड़ा सा विंडोज का अपडेट हो गया था एंड यू नो दैट जब तक विंडोज का अपडेट खत्म नहीं होता वी शुड नॉट बी इंटरप्टिंग एनीथिंग, है ना? इसलिए वी हैव सीन दैट इन द evening class in the app that 5 minutes of delay happened, है ना? 5 minutes of in between the session that problem happened. तो खुद ही विंडोज अपडेट कर देते अपने आप को. ओके चलिए, so let's begin the session. I hope so. Audio and video all good. Can we have in the comment section? There is no problem with audio and video, है ना? Yes, all right. Chaliye, so let's start with today's session, and definitely you will be enjoying the session because mechanics is a subject in which you know the concept, you know the logic. Only thing that will be deciding is the approach. कौन से approach लगाते हैं to solve the question and how you are starting the problem, that is very important, right? Good evening Abhimanyu, good evening. And you have, I hope so everyone is connected on my Telegram channel, and my mail ID is surus.s9@byju's.com, right? Okay. Good evening, good morning. चलिए, this is my Telegram channel and सबने ज्वाइन कर लिया है, so I'm just skipping this part. And yes, ESE mains का result is already being out, and those who have cleared that exam, make sure everyone has registered themselves for the free mock interview with our expert panel. Okay, so can we start with the problem? First question on the screen. Yes, take out the pen and paper क्योंकि आज का questions का level थोड़ा सा अच्छा होने वाला है, and I want everyone to be participating and giving your best in this live session. So first question on the screen is this: a block of mass 5 kg is released from rest from a position A on an inclined plane as shown in the figure. If the coefficient of friction between the block and the plane is 0.2, then what will be the at what point we say the velocity at which the it will touch the ground? What will be the velocity with which it will touch the ground? A simple question from the simple concept of kinematics or kinetics basically. Quickly, a body of mass 5 kg is released from rest, initial velocity equal to 0, right? The position A is there, position B is this one, this is the position B, right? The total length will be L. Let us suppose I am assuming that L, and there is coefficient of friction being applied. The friction hoga, there will be energy loss, work will be done on the friction. Apply the logic and tell me what will be the velocity with which it will touch the ground, the point B. The horizontal height distance is 50 meter, height is 30 meter. Okay. Quickly, everyone. All right. So shall we begin with the solution? Easy question है, देखो simple है, but only thing I want from your side is active participation. तभी ये session में मजा आता है. Now, can we apply the energy balance? If you are having, if let us suppose this is moving, let's say this is your mg cos theta, this is mg sin theta, right? Okay, this is your normal reaction, this is the frictional force, and that is kinetic friction, right? So can we say what will be the retardation? क्योंकि the body is moving along the inclined plane, क्योंकि friction की वजह से will be having some retardation. Can we say that mg sin theta minus f is equal to m into a, right? Okay, or we can say basically this you have to remember. चलो अगर आपको नहीं पता, we can go for this. mg sin theta minus mu mg cos theta is equal to m into a, right? Exactly. Very good, very good. है ना? Perfect, perfect. Quickly, option C. Option C. So we can say what is the value of the acceleration, that is g sin theta. Yes, everyone. Perfect. Very good. Anyone who has completed their, very good evening, Money, good evening. We can assume this is length L. यहाँ से आता है length L ले लेते हैं. नहीं, वो थोड़ा सा कुछ अपडेट आया था, सो अपडेट होते होते थोड़ा टाइम लग गया. Yes. Okay, so let us take a simple approach. इसको और easy कर लेते हैं. Let us take it more simple. Acceleration भी नहीं निकालना. चलो, let me take. If I say the energy at point A will be having, it is released from rest, will be having only mg into the height, that is 30. That will be equal to the energy at point B, that is half into m into vb square, right? But because it has to overcome the frictional energy or friction force कितना होगा? That is your mu into, that is minus of mu into plus mu into f into L. Friction force into L. This is the friction force that it has to overcome, right? So we can say mgh is equal to half m vb square plus mu into n is mg cos theta into L. What is L cos theta? Let's say this is theta. What is L cos theta? That is equal to 50. So we can write it over here as mgh is equal to half m vb square plus mu into m into g into L cos theta is 50, है ना? तो यहाँ से m get cancelled out, so we are getting vb square is equal to gh minus mu g into 50 divided by into 2. Yes, are we getting this? Yes, 20 aa raha hai. Very good. So now applying all the values over here, so 2g, take it as common, h value is 0.3 minus mu value is 0.2 into 50, है ना? Fine. Yes, oh sorry, 0.5, 50 थोड़ी ना, 0.5. Okay, so from here you will be getting the value of this is 2 into 10 into 0.3 minus 0.01, है ना? 0.01, right? Or 0.1, not 0.01, 0.1 under root of this. So near about you will be getting, what's the value? 20 meter per second. Yes, are we getting 20 meter per second? Everyone, है ना? 20. Yes. All right. Done. यही है. Option C is a correct answer. Option C is a correct answer. Very good. Done है. Abhimanyu, Amani, Gaurav, sorry, Utkarsh. Clear? What we is initial energy is potential energy, उसमें it has to overcome the frictional force. So minus F into L is equal to half into M into VB square. That's it. Energy conservation लगाया है, and that is the correct answer. Okay. Yes, done. चलो next question. Next question on the screen. Question number 2. A 30 kg block y 0.5. It is 50. अच्छा 50 meter है क्या? I'm not able to see. 50 meter है क्या? 50 meter. 1 second. L cos theta is 50. अच्छा ये 30 meter. That is the reason I'm saying थोड़ा सा मेरे को ही इमेज नहीं दिखा. This is 30 and this is 50. So this is equal to ultimately 30 minus 10, that is 20. So 20 meter per second. Correct. I was seeing that this is centimeter. मुझे यहाँ centimeter दिख रहा था. It was not visible for me. ठीक है, अब आ गया clear. 20, right? 30 minus 20 is 20 to 20. Root of that 20 meter per second is the correct answer. Perfect. 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 Clear है? थोड़ा सा मैं इधर कर देता हूँ. So I'm not able to see the dimension also. हाँ, perfect है. Next question done. 20 meter per second. चलिए, question number 2. A 30 kg block shown below is suspended by a 2 meter cord to a 60 kg card. Friction is negligible. If the system is released from the rest in the position as shown, what is the ratio of VA by VB? Only the magnitude when the cord is vertical. That means this was the position we are releasing from rest, so it will be coming to this particular vertical position. So you have to tell me what will be the ratio of VA by VB. Okay, quickly, what is the ratio of VA by VB? NAT problem hai, simple question. It is initially at rest, ठीक है? It is initially at rest at this position. I'm releasing from this. So when it is released, so it will be rotating, it will be reaching a vertical position. They're asking you what is the ratio of the velocity of VA by VB when the complete rod, okay, or the cord is in vertical position. Okay, simple, we can apply the conservation of linear momentum. Initially the entire system is at rest. We can say 0 is equal to the MA into VA plus MB into VB. Yes. Okay, but if you try to visualize, if VB is moving on the right hand side, VA will be moving on the opposite directions. We can say minus of this. Okay, fine. So this is equal to MA VA is equal to MB VB. So we can say VA by VB is equal to MB by MA. What is MB? That is mass 30 by 60, that is 0.5. Answer is 0.5. Even if you are not taking the direction, you'll be getting a negative sign. ठीक है, अगर आप direction नहीं लेते, they'll be getting negative sign, but they are talking about the magnitude. तब भी you'll be getting a 0.5 only. Clear? Clear? Understood? Done? Question number 2. चलिए, next question on the screen. Okay, चलो. A turntable is rotating at a rate of 30 RPM. A small block of mass M is kept on this table at a radius R. Given the friction coefficient is 0.1, what is the minimum radius for the mass to just overcome the frictional resistance? I hope so everyone knows what is a turntable. Actually, क्या होता है? There is a table which is rotating. है ना? We are keeping a mass, right? So they are saying that at what minimum radius I have to keep such that the body will just about to slide. Quickly. Question is very easy. Try to visualize. एक plate है. Let us try to understand by this way. There is a plate, है ना? And it is rotating about the central axis. ऐसे करके it is rotating, right? And we are keeping a mass at any distance r. At a distance r, right? So what will happen? What will happen if it is rotating? There will be one force acting on the body, which will try to move this body in the radially outward direction, right? And that will be nullified by the frictional force. Simple question. Okay? So you have to tell me at what minimum radius I have to keep this mass so as the body will just about to slide. Yeah, definitely. I'll be waiting for 2 minutes. No problem. I told you, ask you question में थोड़ा twisting वाले questions आएंगे, थोड़ा logical questions, 2 marks related questions we'll be discussing, right? Yes, Abhimanyu, Mani. Question is very easy. Question में कोई problem नहीं है. Point 1. Okay. Mani Singh B, Abhimanyu and Utkarsh is going with option C. देखो simple. If you try to do the FBD, इसका FBD बनाएंगे. So on this particular body, there is your centrifugal force acting. Fc is equal to mr omega square, and there will be a friction force F. That's it. If I say in the horizontal direction, okay, because the body is in limiting condition, they are saying that just overcoming. The body is in limiting condition. That means we can apply all the equilibrium conditions. So we can say frictional force is equal to mr omega square. What is friction force? Mu into n, n is mg. That is mr omega square. M say m cancel, right? R is equal to mu g by omega square. I think everything is being given. Mu value is 0.1. G take it as 10. Omega value is 30 rpm. You can convert this. Omega is equal to 2 pi into 30 by 60, that is pi. So we are having pi square. Okay, so what is the value? Quickly, 1 by pi square, 0.101 meter. 0.101 meter. That means if I am keeping this mass at a radii of 0.101, okay, or 0.1 meter, तो body will just about to slide. अगर आप इस r से ज़्यादा रखते हैं, let us suppose you are keeping at a radii of more than 0.1 meter, then the body will be sliding outwards. Okay, right? 300 लिया है. अच्छा, okay. Clear है? Understood? Clear everyone? 101 mm. 101 mm is a correct answer. Just we call it, जब कोई शगुन देता है 101 का, तो 101 का शगुन है. 101 mm is the final correct answer. अच्छा, tell me one thing. If I am keeping this mass at a radii of 0.05 meter, if I'm keeping this mass at a radii of 0.05 meter, will the body be in static or in kinetic or kinematic? Static or dynamic? If I'm keeping at a radii of 0.05 meter, the body will be in a static condition or a dynamic condition. This is the first question. And what will be the frictional force acting on the body? That is the second question. Can you tell me? I'm not asking you the magnitude, but thoda logic lagaiye. If the body is kept less than that of this R, the centrifugal force is not sufficient enough to overcome that frictional force. The body will be at rest, right? And whatever will be the centrifugal force, that will be the friction force. Jitna aapka centrifugal force lag raha hoga, that will be the friction force. Clear hai? There's one more possible question that you can expect in this. Let us suppose if I'm keeping this particular mass at a distance of 0.2 meter, then what is the acceleration of this body? That is also you can do. Tab we can apply the Newton's second law or D'Alembert's principle. Clear hai? Understood? Can we proceed now? Chaliye, next question. Question number 4. A box is resting on a floor with a coefficient of friction equal to 0.4. At what maximum height may the box be pulled if it is to move with a uniform velocity without overturning? That means we are talking about the limiting case, and we can surely say what is the limiting case where we need to take that normal reaction. I hope so you know that. Because we are moving this with uniform velocity, there is no acceleration. So can we say that on this body, right, this will be the P force, this will be the normal reaction, this will be the frictional force, right, and this will be the weight of the body, right? Okay, the entire body will be rotating, will be about to rotate about this point too. Okay, clear hai? About the corner point. Very good. 75. Okay, anyone else who has solved? Are we getting h equal to 75? That is option C, or 30 or 60. We can take moment about point O. Take moment about point O because the body is in static equilibrium. Okay, we can say the body is in equilibrium. Uniform velocity means there is no acceleration. So can we say the total moment about point O will be equal to 0? So this is W into 30, this is 60, and this height is h, right? W into 30 should be more than equal to, for not overturning, we can say W into 30 should be more than equal to P into h, right? P into h, right? Right? Perfect. So I can say h is less than equal to W into 30 by P. Or I can say h minimum, or not h minimum, the maximum value. H is less than equal to What's the weight of the body? Weight of the body is, they have not given, W by P into 30. Now, can we say the total horizontal force equal to 0? Total horizontal force, if I try to apply the simple formulation, total horizontal force, so I can say P is equal to F and N is equal to W. P is equal to F and N is equal to W, right? Chalo. So H maximum is equal to W ki jagah we can write it as, we can write it W only. Instead of P, we can write it as F into 30. What is this? W by mu into N into 30. N and W get cancelled out. That is 30 by mu, right? So we are having, what is the value that we are having? Yes, 30 by mu is 0.4. Mu is 0.4. So that is somewhere around 75. 75 mm is a final correct answer. Option C. 75 mm is a final correct answer. 75 mm is the final correct answer. Is this clear? All right. आगे बढ़े. 4 questions done. Chalo, next question. Money, I hope so this is clear. Simple question tha. This is a toppling condition. We can say this is the condition or top or tipping case. Tipping case. This question was basically the tipping case or tipping condition, right? Okay, chalo. Next. Question number 5th on the screen. A block weighing 10 Newton travels down a smooth curved, right, AB joined to a rough horizontal surface as shown in the figure. The rough surface have a coefficient friction of 0.2 with a block. If the block starts slipping on the track with from a point 1, okay, in above the horizontal surface, how far it will move on the surface? Assume G is equal to 1. Okay, this is 1 meter. 1 meter. Okay, चलिए, ट्रस आएगा, थोड़ा सबर करो. It will be coming. Okay, basically this curved surface is smooth. After that we are having a rough surface. यहाँ से यहाँ तक it's a smooth surface, and after this we'll be having a curved we can say rough surface. So they are saying that how far this body will be moving before coming to rest in the horizontal direction. Simple question here. Energy balance लगाओ. What velocity with which it will be reaching at point B, and that velocity will be the initial velocity, final velocity equal to 0, and the frictional force, or we can say retardation, will be equal to mu into G. That's it. Tell me how far it will be moving. A simple question. How far it will be moving? 10 Newton block we are using. Let's say this is VA. VA is equal to 0 because it is released from the wrist. Starts slipping. That means initial velocity equal to 0. And VA is equal to 0. Here we're having VB, and this block will be sliding and reaching at this point. Okay, we have to calculate what is this distance. What is the distance? Good evening, good evening. चलिए यार जल्दी से. Can we apply the energy equation? We can say M into G into H, that is equal to half into M into VB square. VB is equal to root 2GH. Fine. So I can say VB is equal to under root of 2 into G is 10, H is 1. So this is root 20 meter per second. This is the initial velocity. Now what is happening is, this is point B. We are having the we can say resistance, and it has reached at this point. Let's say this is point C, and your velocity equal to 0, right? So they're asking you what is the distance traveled by the body. Velocity आपको पता है, final velocity we know. What will be the retardation? If you try to apply the FBD, one second guys, I'll be back in a minute. 1 second. तेज आंधी आ रही है, so for that reason only there was a huge fluctuations of voltage. नहीं आ रहा? Okay, perfect. अब आ रहा है? Yes, everyone. Okay, what we can do is we can plan this session some other time, because I think there is a problem. in the connection, है ना? All good. Please do let me know आपकी तरफ से if it's a green signal we can continue. If it's a green signal we can continue or else we can plan some other day. No problem with that. Chalo, we were discussing about this problem was now the body is moving with a velocity of root 20 meter per second, है ना? Fine. And the final velocity is equal to 0. Now we have to say, अब देखो, it's a friction force acting on the body. There's a normal force, there's a mg weight, the body is moving this direction. So can we say what is the retardation? Retardation कितना होगा? What will the retardation force? Retarding force is equal to 0 minus f is equal to m into a, or 0 minus mu mg is equal to m into a, or a is equal to minus mu into g. ये आपको हमेशा याद रखना है. Whenever a body is moving in a horizontal direction, so retardation will always equal to minus mu into g if there is no forces being applied. Okay, fine. Chalo, perfect. So a is we calculated. Now we can apply this over here and get the value of this s. Final velocity equal to 0, initial velocity is equal to root 20. Apply करते हैं. Vc square is equal to Vb square plus 2 into a into s. This is 0. This is root 20 whole square minus of 2 into mu into g into s. तो यहाँ से s is equal to 20 divided by 2 into mu value s. What is the value of mu? Mu is 0.2. 0.2 into 10. कितना आया? What's the value you're getting? This get cancelled out. So this is 5 meter. है ना? Are we getting 5 meter? The distance traveled by the block will be 5 meter. Option D is the correct answer. Yes? है ना? 5 meter आ गया? Very good. Everyone has got that 5 meter. I hope so. Now it's called good. ट्रस आएगा आएगा, थोड़ा सबर करो, सबर का फल मीठा होता है ना? चलो नेक्स्ट क्वेश्चन. अरे ट्रस आ ही गया. I told you थोड़ा सा सबर करने के लिए. A pin jointed cantilever truss is loaded as shown in the figure. The force in the member ED. Quickly, what is the force in the member ED? What's the force in the member ED? Quickly. Simple question. Also, you are able to see the dimension. There is one applied force. Now, can we say the force ED will be exactly equal to the force CD? जो आपका ED में member force होगा, that will be exactly equal to the force CD. तो CD निकाल लीजिए. Simple है. Can we apply? देखो, we can say this is FCD, this is FCD, this is FCB, है ना? We can take joint C, and get the value of your FCD, and FCD is equal to FED. Quickly, FCD will be equal to FED. 80 Newton. Okay. Simple question है. Simple question है. This is angle equal to 45 degree, है ना? So we can say FCB sin 45 is equal to 80, है ना? Fine. And FCB cos 45 is equal to minus FCD. Take the ratio. We can say tan 45 is equal to 8. Net चला गया. Yes, I think now it's working. हाँ, चलो ठीक है, perfect है ना? 80 kilonewton, and the nature of force is compressive in nature. The nature of force is compressive in nature. Please make sure that nature of force is compressive in nature. Compressive in nature. All right, clear है? Question number 6 done. चलो question number 7 करते हैं. हाँ, this is an interesting one. Two forces of magnitude F are acting on a uniform disc rolling without slip on a horizontal rough surface as shown in the figure. The frictional force by the horizontal surface on the disc is. Actually यहाँ पे ना बहुत तेज बारिश हो रही है. It was forecasted 7 बजे होगा, but I think just 4 minutes back it started and it's like completely dark outside. और कभी कभार क्या होता है ना, when it is heavy voltage, तो कभी कभार इन्वर्टर भी बोल देता है कि voltage fluctuation की वजह से. I hope so that will be good. So we won't be able to cover much questions, but I'll be giving you some question as an homework. Okay, so definitely we can say this will be the friction force. This will the friction force. So I can say the total summation force, that is 2F minus F is equal to M into A. M into A, right? And we can take this is point O, we can take moment about point O. Moment about point O, that is equal to IO into alpha. F will be creating a clockwise, this friction will be creating a clockwise, so we can say F into R plus small f into R is equal to, this is this, that is m r square by 2 into alpha. R get cancelled out, so we can say F plus small f is equal to m into R into alpha by 2, or I can say this will be equal to F plus f is equal to m into A by 2, this over here, or I can say 2f plus 2f is equal to ma. From equation 1 and equation 2, what we can say that 2f minus f is equal to 2f plus 2f. This get cancelled out, so f is equal to 0. F equal to 0 means they're asking you what will be the value of m. The friction force is F into F. So friction force is equal to N into F. So N is equal to 0 because our friction force is 0. Okay, right? So we are getting this value to be 0. All right, we are getting this value to be 0. Okay, done. Very good everyone. Chalo, next question, question number 8 on the screen. Achha, before going to 8th question, I think Dheeraj sir already is live on the workshop, right? And this Sunday we're having the scholarship test. Do join that. Answer yaad tha? Okay. On the app, I hope so you have seen this class has been done. So tomorrow we'll be having the heat transfer in the app class. This is the schedule we have already shared with you guys. तो अगर आपने नहीं किया, कल हमारा इसरो का 4 बजे heat transfer का practice session. Okay, चलो next question. This is an interesting one. This is an interesting question. Please do let me know what will be the answer. The figure below shows a small spherical ball of mass m rolling down the loop track, and this is that spherical ball. दिख रहा छोटा सा but ये है. This is that spherical ball, right? It's released on the linear position at a vertical height h from the lowest point. The circular part has a radius r. The tangential acceleration of the center when the ball is at point A. That means it rolls down and it reaches at this point. What will be the tangential acceleration? Try this question. अच्छा है, बहुत अच्छा question है ये. This is an interesting one. Quickly. There is a spherical ball which is kept at a height h. It is rolling down and it is covering that loop. ऐसे करके जाके it is reaching at point A. They are saying that when it reaches point A, what is the value of the tangential acceleration? चलिए, let's try. Let's try. Energy balance लगा दीजिए guys. Energy balance लगा दीजिए. Quickly apply the energy balance and tell me what is the answer. I think थोड़ा सा cheap सा दिख रहा है क्या? Let me see from my end. ठीक है, all good. Quickly. नहीं money, it's all good. I've seen from my mobile phone also. It's all good from my side. How to proceed? देखो, can we say because it is released from the height h, so there is no velocity, only potential energy, right? So we can say mg capital H is equal to, now let us suppose it is reaching a point A, it will be having some velocity, and what will be the potential energy? This height will be we can say sine theta, and this height is r, so total height will be m into g into r plus r sine theta. Yes, r plus r sine theta, है ना, right? अब अगर यहाँ पर ये पहुंचा है, what is this distance? That is r sine theta, and that r, so that is the potential energy plus half m v square plus half I omega square, है ना? Money saying option B. Anyone else? minus 5 by 7 g cos theta minus 5 by 7 g sin theta. Okay, चलो देखते हैं. Now, so we can say this is mg h is equal to mg r 1 plus sin theta plus half m v square plus, acha, what is the moment of inertia of a solid sphere? What is the moment of inertia of solid sphere? Can you tell me? Solid spherical ball का moment of inertia कितना होता है? Quickly tell me the answer. This might be the last question because I think थोड़ा सा इशू है बीबी, यू गाइस आर टेलिंग मी, है ना। चलिए 2/5 mr square, it will be 2/5 mr square into omega square, है ना, fine, right? And we know that because this is rolling motion, this is rolling motion, कहीं लिखा है ना rolling motion, so r into omega is equal to v, or v is equal to r omega, है ना। चलिए, so we can say mg capital H is equal to mg capital R 1 plus sine theta plus this will be v square, so 2 get cancelled out, this will be 10 7/10 mv square, 7/10 mv square. Now question is they are asking you what's the value of angular acceleration or tangential acceleration, that means you need to calculate r into alpha, यही है r into alpha, है ना। फाइन, चलिए क्विकली हाउ टू प्रोसीड, कैसे करें, क्वेश्चन इज वेरी इजी नाउ। हाँ, बस आपको क्या करना है, यू नीड टू जस्ट डिफरेंशिएट कीजिए एंड टेल मी, डिफरेंशिएट विद रिस्पेक्ट टू थीटा, differentiate with respect to theta, so differentiating with respect to time, so this is equal to 0, this will be equal to mgr 0 plus sine theta, differentiation is cos theta d theta by dt, right, plus 7/5 mv into dv by dt, है ना, fine, yes, perfect. So we can say over here, one second. All right, chalo quickly. So now we can see this is equal to 0 is equal to cos theta d theta, है ना, that is mg capital R plus 7/5 m into v dv by dt, ठीक है। अब आ रही है ना, वो मैंने एक्चुअली थोड़ा सा एकदम से ना भी लाइट आ गई है तो थोड़ा सा प्रॉब्लम हुआ। So we can rearrange this equation, minus mgr cos theta d theta by dt, that is nothing but your alpha, है ना, that is nothing but your alpha is equal to 7/5 m into v, and that is yes, okay, yes, right. So m get cancelled out, your r into, sorry, this is omega, and r omega is equal to v, this is equal to v, this is also get cancelled out, so we can say this is minus g 5/7 cos theta is equal to acceleration. Are we getting this? Minus 5/7 g cos theta, minus 5/7 g cos theta, option A is the correct answer. Yes, option A, it is not B. Option A is the correct answer. Clear hai? Option A is the correct answer that we are getting over here. Clear? है ना? Yes, everyone. आ गया? This was an interesting, I told you today we'll be solving some good level of question for the GATE examination, because jitna acha level question you will be solving, the more understanding you will be getting. Next question done? अच्छा एक हो गया, चलो next question, question number 9 on the screen. A mass m is suspended from a ceiling through a string at length L. This mass moves in a circle on a horizontal radius r at constant speed such that it is in a conical pendulum. What will be the tension in the string? What will be the tension in the string? this T value. Quickly, what is the tension in the string? Quickly. What is the tension in the string? Yes. Everyone. Let us suppose this angle is theta. This angle को ले लेते theta. This is mg, है ना? So I can say, because the body is moving with a constant speed in the horizontal direction, we can say T sine theta is equal to mg. This is radius r, this is length L. I can say T sine theta is equal to mg, right? Okay, fine. Or T is equal to mg by sine theta. That's it. So what is sine theta? Sine theta will be equal to under root of L square minus R square divided by L. This is the value. mgl divided by under root of L square minus R square. mgl divided by under root of L square minus square. Option D is the correct answer. That's it. Clear है? A simple question. ये तो easy था. Yes. Okay. Done. Perfect है. Next question. Question number 10th. देखो, by looking at the option, it looks like कि कितना difficult question होगा, है ना? By looking at the options, it seems like it's very difficult one, but by after drawing the diagram, देखो mechanics में always remember that if you are not drawing the diagram appropriately, you won't be getting the correct answer. The approach won't be correct. Okay, चलो next question. चलिए, try this one. Try this one quickly. Try this one. A solid block of A weighing Q is resting on a flat floor, and a smooth cylinder B weighing P is placed between the A and vertical as shown in the figure. This is the figure that we are having. This is the figure that we are having. Okay, there is a solid block A. This is the solid block A, and we are having a smooth cylinder. There is no friction. Okay, this is a smooth cylinder B. They are saying that the friction between the cylinder wall and the block is negligible. The coefficient of friction between the block A and the wall is mu. Then what is the minimum weight P required to disturb the block A? What should be the minimum value of P so that the block A will be disturbed? That means limiting condition. That means we have to go for that limiting condition. Try this one. Try this one. Question is easy. Try to draw the free body diagram and you won't be having any problem. Try to draw the FBD. The FBD for this cylinder will be having this as the reaction by the wall, the weight P, and your this one. This is your RA. Let us take it as RA. Okay. This angle is theta. So they are saying this angle is theta. This is theta, right? Fine. So this angle will be 90 minus theta. So this is theta. Okay, right? Chalo, quickly. So can we say P is equal to R cos theta? है ना? 1 second यार, फिर से दिक्कत होगा. I'm waiting quickly. चलिए last question है guys. There is a huge fluctuation of voltage going on. बहुत तेज बारिश हो रही है. I don't know when it will be. इंटरनेट का फ्लक्चुएशन हो सकता है. So we can say because the entire system is a limiting condition, can we say P is equal to RA cos theta? This is one equation. है ना? Draw the FBD of this particular block. If I try to draw the FBD of this particular block, question बड़ा easy है. Question is not difficult. और इससे भी खतरनाक क्वेश्चन थे आज. but due to this heavy rainfall, we won't be able to. This one. Yeah, RA, same RA will be acting from the CG point. Same RA. This is your RA. This is, let me write it as Q. Q. And the horizontal will be the normal reaction, and this will be the friction force. That's it. यही है. Okay. हाँ, लगा सकते हो, कोई दिक्कत नहीं है. You can apply, but for that 3-4 system you have to convert the normal reaction and the friction force का वो condition जो है ना, resultant वाला concept लगा सकते हो. Right. चलिए quickly, what is the value you are getting? What is the value you are getting? Just we need to do the force analysis. Do the force analysis and get the value, and eliminate the options and get the value of P in terms of Q and mu and theta. Q, mu और theta के बीच में try to create the relation. So what is this angle? This is theta. This is theta. ये आपका theta है. This is 90 minus theta. This is also theta. Okay. So can we say RA cos theta is equal to F, and normal reaction will be equal to Q plus RA sin theta. Yes, can we say like this? है ना? Okay, all right. है ना? हाँ, ठीक है. Is this clear? Just we have to resolve. Wait 30 seconds. Definitely I'm waiting for 30 seconds for. बस आपको concept लगाना है. So now we can say using these two equation, that is option B. Option B. So we are getting F is equal to RA cos theta, that is mu into N, that is RA cos theta. What is mu into N? Mu into N is Q plus RA sin theta, right? And what is RA cos theta? RA cos theta is already P. We can write it directly as P. Fine. So now we can eliminate this value of RA. So mu into Q plus RA की जगह we can write it as P by cos theta. So P by cos theta into sin theta is equal to P. So mu Q plus mu P tan theta is equal to P. So P is equal to mu Q upon mu tan theta, 1 minus mu tan theta. Okay, mu Q divided by 1 minus mu tan theta. Option B. Option B. Are we getting option B, everyone? Option B is the correct answer. Mu Q. एक tan theta और missing है क्या? No. एक second. Yes. Okay. I think there is one tan theta additional they have written. एक tan theta additional है क्या? Please do check your answer and tell me the correct answer. P by tan theta mu Q. अच्छा, एक tan theta additional, I think this is one tan theta is additional over here, है ना? One tan theta is additional over here. Is that so? Yes. So we can say option B is the correct answer. एक उन्होंने printing mistake कुछ किया है. Mu Q by 1 minus mu tan theta. Yes है? Clear? Option B, everyone is getting. Question कोई difficult नहीं था. Only you have to go step by step. Only we have to go step by step. Are we getting tan theta in the numerator? अगर आ रहा है तो we can cross check our calculation over here and we'll be getting the answer. Mu Q tan theta आ रहा है. चलो देखते हैं. Let us cross check. So mu into Q, RA is P by cos theta, this is P tan theta. RA cos theta is equal to P. So we are having this as to be mu N. Yes, mu Q tan theta upon 1 minus mu tan theta. RA cos theta is equal to this. RA cos theta we can write it as P. Mu is equal to Q plus P. RA cos theta P tan theta. अच्छा एक एंगल P is equal to RA sin theta by Lami's theorem. You can cross check over here na. P cos theta is equal to RA cos theta na. This is theta, this angle is theta, this is 90 minus theta, this is theta, right? चलो एक बार चेक करते हैं, let us cross check. वोल्टेज फिर फ्लक्चुएट कर रहा है. Please check, are we getting option B, everyone? है ना? N is equal to RA sin theta plus RA sin theta plus Q. RA sin theta plus Q, that is the value of N. यार एक बार देखो, आर वी हैव R cos 90 minus theta, that is P is equal to RA sin theta, that's it. यही है? Yes, RA sin theta. So RA sin theta यहाँ पे place करेंगे, so we are having some changes in the value. So this is equal to P by tan theta, है ना? We can write it like this. P by sin theta into cos theta, that is P by tan theta, and that is equal to P, because RA sin theta is equal to P, and RA sin theta is equal to P. So place it over here. We are having P into this. This is, हाँ अब ठीक है. आज इंटरनेट बहुत ज़्यादा फ्लक्चुएट होने के कारण ना वो भी नहीं हो रहा. सो म्यू इंटू क्यू इज इक्वल टू म्यू P tan theta minus mu into P. So we are having the value of P is equal to mu Q into tan theta divided by 1 minus mu tan theta. Yes, we are getting. अरे नहीं बहुत ज़्यादा फ्लक्चुएशन हो रहा है ना, तो पीछे से ही नेट का इश्यू चल रहा है, उसमें कुछ नहीं कर सकते. वो इतनी तेज बारिश हो रही है, अंबानी भी बोलेगा भाई इतनी तेज बारिश में तो मैं भी टावर पे खड़ा हो जाऊं तो नहीं कर पाऊंगा कुछ. Okay, so option B is the correct answer. So we have covered the 10 questions. So I'm giving you some questions as an homework, right? Question number 11th, question number 12th from the trust topic, question number 13th and question number 14. 13 interesting hai. 13 is a very interesting question, so try to go for that. And you can download the PDF on my Telegram channel. This is the crash course that we are having. Okay, fine. 2 months back ही I've just relocated to Chennai. तो यहाँ पे बारिश बहुत होता है यार. यहाँ पर बारिश and fluctuation of the voltage is very high. So मेरा इन्वर्टर भी बोल गया है 1 महीने में. Right? चलिए. So this is it from my side. Do download this PDF, try this question, and you can send your responses, and I'll be happy to help you out. And if you have any doubt in any of the question, you can write in the comment section. So this question I'm having doubt. We can take that problem directly in the live session. Okay, fine, right? नहीं अभी just it's a beep sound आ रहा है कि भाई बंद कर दो. Right, चलिए, thank you, bye bye, take care, and you can practice